As a big chance. All right, so anyway, should be 3 minutes. Right, just a quick review on how we did last day. Right, you're here and right online. Nobody be messaging. I think I'll pick on them one by one. Amanda, you two not responding. Brianna, there, okay, good. Emily, you there? Right, you all here and right. Michelle message, not please. Right. So last day we stopped at the exponential function we did in the seed, right? We learned about this function here, which is what Shivish. What's the equation for that function? And so you come a little closer, right? In the next class. Yeah. Y is equals to 8 to the power of x. Right? So any function of that form will look like that. Okay? Right. Today now we have, and I did a couple of questions on how to solve the DM something. I didn't do any of those. I did one. Okay, I'll do one next one when I do lawn. I want to show you how to solve lawn as well, right? Right. So today now we're gonna do a function that is inverse of y is equal to the x. Right? And you all might remember from math. So you all did the function and I'm gonna take that off, right? Yes. Right? Inverse of a function is the reflection. So if I reflect y equals to 8 to the x, if I reflect y equals to 8 to the x in the line, y is equal to x, I will get y is equal to log 8 to the x. Right? That's a log function. Okay? So how are they related? Log 8 to the x is the inverse of 8 to the x. Alright? They are the inverse of each other, and that's what the graph looks like. You have to know this graph, sir. You have to know this shape. Okay? Huh? Yeah, that's a good idea. That's what we do. Do you think come back again? Not my shape. Oh, my fish on there. Huh? One out there because anybody writes in there? Yes, sir. Oh, yeah, please. All right, so today we got to focus on logs and something called log, right? Am I trying to? All right, so let's take a look at logs. First thing first, let's run over logs. We need to remember firstly how to go from exponent to log, right? So we need to be able to go from one to the next. So if I gave you ax is equal to b, let's say a to the b is equal to c. To convert to the log form, what do we do again? To convert from this to log, what do you do? Right? Bring down the a becomes the base, bring across the c becomes the value you find the log of, and b is the answer. All right, let's do something that we know. Let's say 5 squared is equal to 25. If we convert this to logs, this will be equal to log of the base 5 to 25 is 2. All right. So we need to be able to convert from one to the next. All right. Check this one out. What will this be? What will this here be? Log to the base 5 of 1 is 0. No, bring across the 1. So log to the base 5 of 1 is 0. Just try one more because Nikolai get it wrong. 5 to the power of 1 is 5. What is that? Log 5 is what? Right? Log 5 is 1. Okay? Log 5 is 1. Okay, so that brings us to some rules. Let's do the rules that we know already. Look at the last one. Log to the base a of a is always what? 1. Log to the base a of 1 is always what? 0. Look at there. Log to the base a of 1 is always 0. Right? Next rule. You gotta remember this rule here. M to the power of n. What is do with the n? Bring the n in front. So that's log to the base a of m. All right, number 4. Log to the base a of m plus log to the base a of n. Same base addition sign. So what you do? Multiply. All right. Yeah. One must come back. Should be good. Oh, I'm going to go over people things that do scroll down. Right? What's this here? Log to the base subtract log to the base a of m divided by. Are you okay with that? Yeah. What about this rule here? What is log to the base a of m divided by log to the base a of n? What will that be? Same base and divided. What to do? No, that's not a rule, right? This is not a rule. There's no rule for this. No? Minus is when it's like this. So this is not a rule. So do apply the rule here, right? I'll just write it to what does it? Right? Only if you have multiplication, it can be broken up to give you addition. Right? Not log of something divided by log of something. Right? That's not the rule. Number 6. There's a new rule. It's called change of base. So sometimes we will not have the same base and we are limited to change it, right? Sometimes we have to be able to change it. So let's do the change of base. Let's go from base A to base C, right? So if I give you a log to the base A of M, what will that be? Right? Watch this here. If you have to change the base from base A to base C, it becomes log to the base C, log to the base C, right? I'm changing to the base C, right? So I'm taking up A and I'm putting C. What goes here is the whole number. What goes here is the whole base. That's okay? So you want to convert log A to the base C. You put the C and the C here, whole number here, whole base here. For example, let's try to convert this to the base 10. Right? What will log of 100 to the base 5 be? You want to convert to the base 10, right? Log 10, log to the base 10. The whole number goes here, and the whole base goes here. And you work it out. Check it in the calculator and see. Check it in the calculator, see what you get. Check it in the calculator, see what you get. Check it and see. You have to be able to prove this formula too, right? So, let's should be someone else over there. The last thing that we're going to learn is that everything that we do here, we can do it for something called ln, right? And the reason we can do it for something called ln is that log to the base e is simplified as natural logarithmic or ln, right? So every time it's ln, ln is the same as log to the base e. All right. If I give you a question with ln, you could use all these rules with ln. All right, all these rules here with ln. So every single one of these rules could work with ln. All right. So log to the base e of x is ln x, and I'm going to show you how to. I just want to show you how to do that, right? Right. Most people might be familiar with simplifying ln, but maybe log, maybe not ln, right? So let's start here. What do you think is ln e? What do you think is ln e? Yeah, 1 y. All right, very good. Aryan said that ln is log to the base e. So log to the base e of e is 1. Nice. Okay. What about ln e to the 5? What will that be? Right. This 5, I can use the cover rule. This 5 come in front and it will be 5 ln e. And we know that ln e is what? 1. So the answer is 5. That's okay. What about let's try and simplify this as far as we could. Ln x squared minus ln x. Copy it down. Let's try that. right? So what does it simplify to? Right? You have a few options. You can take it 2 and put it in front and simplify it. Or ln subtract. You can use this, right? You can use here. Same base, subtract sign. All right? So we could use ln x squared over x. This will cancel, right? So you'll get ln x. Okay with that? What about if we have to solve something like this? 5 to the x is equal to 4. What you do here? I'll take ln and take logs on both sides, right? The problem here is that we can't convert 4 to the base 5. Okay, nor 5 to the base 4. So what you have to do here is you're going to take logs on both sides. So you're going to get log 5 to the power of x is equal to log 4. Right? You can take the x and bring the x down here. Right? And then make x the subject. So x is equal to log 4 over log 5. I'm Nikolai. I bring the x in front and I carry across. Right, but here's why I show you that, Nikolai. Suppose I asked it this, Nikolai. E to the 2x is equal to 4. How do we solve for x? So instead of taking log, we take log. Right? So instead of taking log, we take log, right? Let's make sure online everything there to kill an hour drama. Right. So instead of taking logs on both sides, we take ln, right? So we'll get ln e to the 2x is equal to ln 4. I could take this 2x and bring it in front here. But what is ln e? Ln e is 1, right? And ln 4 is something in the calculator, right? So x is equal to ln 4 over 2. Okay? I was trying to get you a little familiar with using ln, right? Copy it down. Finish. Right, so if you see a ln question, same rules that you would apply for log, you apply for ln. Okay? So let's make a note of that. The same rules apply for ln that would apply for log, right? Same rules. So we just gonna build up and do some questions, right? Superior, get you that? Superior, listen. Nice, superior. Panama. Panama, Panama. We can add my calculator again. Pass on calculator. Sorry, not add one. All right, nice. So let us start taking a look at some questions, right? Right, some will be simple, some will be a little bit tight, right? Yeah, everything I can do with log, you can do with log. Huh? Yeah, that's a good idea. Think about it, right? Yeah, but you ready now? All right, so let's start. 2008 first, right? So the first one that we're going to do is 2008. I'll guide you along. In fact, you will tell me how we could solve this, right? Log to the base 5 of x plus 3 plus log to the base 5 of x minus 1 is 1. How are we going about this here? What's the first rule we can apply here, Shabish? What's the first rule we can apply here? Addition sign. So what to do? Same base. We could yes. So we have the same base addition sign. So it will be log to the base 5 of x plus 3 by x minus 1 is 1. Right? When I reach here, what to do? Kill it. Expand. All right, yeah, and then what? Anybody remember how to do this? So when you reach here, you have two options. You can take this and convert to exponential form, right? And then solve it. Or instead of writing 1, you could write log pi 5. Because we know 1 is log pi 5. And since we have log on this side and log on this side, we could cancel logs. And then you will expand this out. Then expand this out. X squared plus 3x minus x plus, minus 3 is equal to 5. Right? So look what I did. I made sure that the same log and cancel off. Right? And then we get a nice little quadratic that's x squared plus 2x minus 8 is 0. And you solve it, right? Most likely you could probably factorize. X is what? Positive 4, x is minus. So we got 2 and minus 4, but we have a slight problem. What's the slight problem with the two answers? All right. If you remember the log graph, right? The log graph doesn't exist on the negative side. Right? So you can't find log of a negative number. So if you put 2 in here, it works out nicely, right? That's okay? But if you put minus 4 in here, you're getting negative values. So it will not work here. So therefore, the only solution is x is 2. Online? Okay, we'll on there. Tabisha, right? Nice. Thanks for replying, Tabisha. I heard it before, sleeper. Kalia, you okay? Samira, are you okay there? So we should have put us into there. All right. Everybody okay with that? But what will happen if it's not the same base by Shabish? If it's not the same base, what to do? Can I apply the rules if it's not the same base? So what I could do? Huh? Ariane, what to do? Change the base. You can change the base. All right. So if you do get the same base, all you have to do is change the base and apply the rules. Anybody here? When they're here, don't need like buses. All right, let's go again. Any questions online? I'll give it a tricky part. Or should I give it a tricky part one time? One time? Right. Here's what they ask. I want to write it here because it's a fraction as well, right? They said do not use calculators. Do not use calculators. And they want you to evaluate it. Can I put it here, boy? Log to the base 10 of a half plus log to the base 10 of 2/3 plus all the way down until, you'll see that? Log to the base 10 of 9 on 10. So this is 9 on 10, right? Oh, let's see now. I can barely see it here. Yeah? You're seeing this online? So they want to know when you add up log to the base 10 of a half and then 2/3. Actually, guess what? Anybody writing it? I want to write it properly, right? Well, this is 2008, right? I want to write it properly. I cannot leave out 2 terms so you might can see the pattern. Log to the base 2 of a half plus log to the base, sorry. Right, what's the pattern here, right? 2 here, 2 on top, 3 here. Log to the base 10, right? 3 on top, 4 underneath. And you keep going, and you will keep going until you reach log to the base 10 of 8 or 9. 8 or 9 plus log to the base 10 of 910. No calculators. We have to be able to use the log rules and simplify this out. Giving you 2 minutes. Let's see what we come up with. Try and use the log rules and simplify this out. Don't worry too much about what's happening here. What happens here will happen down here. So do write out 5 and 6 and 7 and do write out. All right? How are we going to work out something like this? Huh? Same base, addition sign. Try in your book and see what you get. Online, if you figure it out, you can message. How hard is it? Like 4, 5, 11. Right. Just apply the log rule. Same base, addition sign. If you are looking. And they all have the same base. Addition. So what you'll do? And then see what happens. Huh? You can do that for yourself. You'll see what happens. Do it for yourself. Something automatically happens. Right online? Let's see what will happen. So what you recognize? Everything can cancel. Not everything. Right? So you have 1 on 2. Addition means multiplied by 2 on 3. Addition means multiplied by 3 on 4. Multiply by, in fact, I'm doing one more because I want you all to see it. In fact, let me do it. I want you all to see it. But you don't have to do this in the middle, right? You don't have to do the whole thing. What you will recognize here is what? This will cancel here. This will cancel here. You all recognize that? So all will cancel except with the smallest and the largest. So that will be, no, you don't have to write all this. You just write in these 3 and you will see the pattern. Write these 2 and you'll see the pattern. So you're going to be left with log 1 over 10. How much is that? So you're going to get log to the base 10 of what? 1 on 10, there are 2 options. You could write it like this. Or you could say 10 to the minus 1. Log to the base 10 of 1 is 0. Log 10 is. So the answer is minus 1. Nobody get a 1 line by? Ishmael? Yeah. What marks हो गया? What's that true? I know, I don't know. Okay, one correct, all right? Okay, one the last part. But you do all the hard work already. All right, let's go again. 2010. 2009. Sorry. Online. Any questions there? When you fill me a message in. Kevin, you listening? Amanda, you okay? Samira, you okay there? All right, let's go again. 2009. right? This is log to the base 4 of x is equal to 1 plus log to the base 2 of 2x. Question said that x must be more than 0, right? Try that, please. Right, we have a problem there in the beginning, right? What the problem here should be? What the problem with this question? Yeah, so we have a slight problem here, Nikolai. Okay. We have a slight problem with this question. What's the problem? Adam? Adam or Ada? 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 Adrian. Adrian. Yeah, different beats. Right? So there's a problem here, Sarah. Different beats. Right? It's up to you. You can convert the 4 to 2 or 2 to 4. Normally, it's convert the bigger to the smaller. All right? So convert base 4 to the base 2. What will that be? What will that be? Log what? Log 2 here, log 2 here. What do I write here? What do I write here? 4. Simplify it out. Simplify it out. 1 plus log 2 to x. What is log 2 to the power of what is log 4 to? 2, right? Because 4 is what? 4 is 2 squared, and I can take the 2 and bring it 2 here. Sorry. That's okay? You're saying that? Watch it again. I had log 4 to the base 2. Instead of writing 4, I could write 2 squared. Right? And I could take this power here and put it in front. Right? So we're getting log to the base 2 of x all over 2 is equal to 1 plus log 2 to the 2x. Yeah? Sorry? If you want. You can do that. But I won't do that. Okay. Do we like fractions? Yeah, you like fractions? So how will get rid of fractions? Multiply everything by 2. So multiply everything by 2. We'll get log to the 2x is equal to 2 plus 2 log to the base 2x. What's the next step? Any question? Any question is simplifying. Bring all the what? Bring the logs together, right? Any question you're doing, you're bringing like terms together. So you're bringing your logs together here. Log to the base 2 of x. Bring across the plus, it becomes minus. Log 2 to the, sorry, I want to leave it 2 here and I'll show you something after, right? Is equal to, okay, when you have minutes, if you can simplify it out. Last minute, I'm showing us now. All right, let's see how this went. So, I was saying that, right. So now we have log to the base 2 of x minus this 2 becomes power, but a common mistake is that when you put the power, you just put 2x squared. But remember, it's the power of the 2 and the x. Okay? Is equal to 2, and you can write log 2 here. Right? This will allow you to have everything in terms of log. So this will be log to the base 2, subtract, same base. So we're going to divide. That's 4x squared. Bring this 2 here, and you will get log to the base 2 of 2 squared. This will cancel with this, and you'll get x over 4x squared is equal to 4. Right? If you want, you can just cancel it up here. But I don't want to cancel up in case we lose a solution. So I'm multiplying it out, cross multiplying. I'll get 16x squared is x. I'll get 16x squared minus x is 0. When you solve this, you'll get x is 0 and x is 1. Sorry. Yeah, x is 1, 6. Right? But the question said x must be more than 0. So the only solution is x is 160. Right? So watch this here. All I did is I bring the logs together, and I took the power and put it here. And I expand this out. Right? When I expand it out, minus same base, so I divide. Okay? And then I carry the 2 here and I drop off the logs. And I solve. Okay? The reason I didn't cancel the x here is I didn't want to lose the solution. Right? And sometimes when you simplify and cancel it off, here's the solution. Can't avoid that. Ready? Let's go again. Let's start here. We kind of did it already, but it's part 2 we did too. Okay, 1 and 2. Yeah. 1 and 2. Oh, well, yeah or no? Sorry, I don't know the year. Might be 12, I think. Yeah, it's 12. Right, so part one is supposed to be easy. Anybody get it? All right. Exactly what you did in part one. What you got in part one. Right, that's similar to what we just did on the board. Right, I give me a few minutes. Right, part two is just a longer version, right? Okay, yeah. Arya, very good. Arya, not. That's where you went. Anybody want another answer? So the first part's simple, right? Because the 1/3 by the 3/5 by the 5/7 by the 7/9 by the 9/10, right? And we learned before only the smallest and the largest will remain. That's log to the base 10 of 1/10, which is -1. All right. So what does this mean? What's the first value? What's the first value in this term here? When R is 1? 1 over what? 1 over R plus 1, which is 1 over 2. That's okay? What's the next term? Log to the base 10 of what? 2 over, no, next term, remember it's from 1 to 99. So it's 1, 2, 3, 4, 5, 99, right? Until it reach 99. So it will be 2 and how much? 3. And then we go in what? All the way until we reach 99 over 100. So what will remain? 1 and 100. This will cancel, right? You'll end up with 1 and 100, which is -2. All right, nice job. Somebody get it online. Supreme guy, nice. Somebody else get you Christopher guy. Killing, you see, you get things wrong now, killing. All right. Are we good? Right? Yes, so that's the way you work it out, right? Again, if you're not this looking straight, right? But you should know the summation symbol and you should be able to expand it out. Right? So always try and list out a few, right? And see what happens. Right? Let's do a hard one now. Ignore the first one. Try part 2 and 3 first. Ignore part 1, right? Part 1 is the hard one. Sorry, ignore this here. We just doing it e to the x and the log. E to the x and the log. The log should be easy, right? Division. Log easy. Underneath here. If it's good thing, boy. Then part 1 look like this guy is quadratic, right? So part 1 looks like this guy is quadratic and part 2 is a normal log. Right? The reason I didn't do part 1 last week is I didn't show you the log again. So part 1 is like what we did last week. Right? So the first one, let y equal to e to the x and yeah, quadratic and root. Huh? First part, right? So doing part one first. Let y equal to e to the power of x. So we are going to get y plus 1 on y minus 2 is 0. Right? We do like this fraction, so we can multiply. So we can multiply everything by y, and you will get multiply everything by y, and you'll get y squared plus 1 minus 2y is 0. This is a quadratic, and you get y to be what? 1. That's it? Just 1? Right. But you can't just leave the answer as y is 1. What you have to do? Right. You write it back. Make a substitution, and you'll get y is 1, right? Or e to the x is 1. How do you solve questions like this now? E to the x is 1. Take ln on. Take ln on both sides. So you'll get ln e to the x is equal to ln 1. X is equal to ln 1 or 0. Answer is 0. Right? You'll get x by ln e is ln 1. Ln e is 1 and ln 0 is ln 1 is 0. Right? Ln 1 is 0. Next one. Next one, we have log 2 x plus 1 minus log 2 3x plus 1 is 2. This one easy because they both in the same base, right? Right? Same base. What you do? Right. Same base, subtract, we divide. Right? I just going to try the next technique here, right? I'm going to convert to exponential form. Right? So I'm going to go from logs to exponential. And just go in the reverse. Just to give you a different technique, right? So remember, this 2 will come up, this 2 comes back across, and the answer is x plus 1 over 3x plus 1. So you're going to get 4 and 1 is equal to x plus 1 over 3x plus 1. Cross multiply, and you'll get 12x plus 4 is x plus 1. You'll get 11x is minus 3, x is negative 3 on 11. X is minus 3 on 11. All right? Yeah. They're moving it up. Well, no. The base coming up and the answer coming out the power. So that's how I got 2 squared. So the table is now 3 squared. 3 squared. Right? And then it was got it that part here. Copy down and then one more part. One more part, right? Anybody writes in? Copy that part. All right, last part. Right, look at the first one. 5 marks. It's a little bit challenging. Look at the first part. A cubed plus B cubed plus 3A squared plus B is that. It's a proof, right? It's a proof. They wanted to prove that this is equal to this. So because it's a proof, you have to start. Excuse me. Exactly. So you have to start here, the proof, right? You have to start right in. You have to show that this is equal to this with the help of this. That one. We have a next one later on, but it will learn. Same thing. Right, so you have 5 minutes. Let's see if you get it. If you get it online, must QED, right? Aaron again, true? Okay, so you're starting right there. One of Aaron's coming. Aaron, you there? So you're taking the part in the that are set to start, and we're starting. And you have to find a way to make that look like the right hand side. I just be trying to start with the right, start the correct side, right? 3 log A plus B. Start with that. Yeah. For the next paragraph, to do one thing. I found about 7. It's one hard. Right? Because you have to understand what it's saying, right? You have to take this left hand side and you have to show that side in. So when you reach here, what you can do is what? When you reach here, what you can do? Take a trim first here. So you'll get log to the A plus B all over 2Q. That's okay? That's what you get, right? So by looking at this and looking at this, what you probably have to do here, you have to cube the A plus B all over 2 cube, which is 8. So there must be a way for us to expand this out, right? So how we expanding a plus b cubed? How you expanding a plus b cubed? A plus b by a plus b. If you leave the 3 in front, you'll get the same thing. Was that possible? I'll leave the 3 in front, right? Oh, no, you can't. Oh, I mean, if you break it up like that, okay, yeah, all right. So you break up the division, you use division, then you break it up. All right, I can do it. But you still have to go and expand out, right? Right, so yes, so you have to expand this out. So focus on 2 first. When you expand out these 2, you'll get a squared plus 2ab plus b squared, right? This by this, and so on, right? Multiplied by ab. So you have to multiply this by ab. So a by this is a cube plus 2a squared b plus 8b squared. So I multiply a by this and this and this. Then I'm going to multiply b by this and this and this. So I'll get a squared b plus 2ab squared plus b cubed. Right? See if any like terms that I could bring together. Right? I just bring in the cubes together. And I have 2a squared b plus 1a squared b. That's 3a squared b. And I have ab squared plus 2ab squared. So that'll be 3ab squared. All right? So that's all the help I can give you. So we can figure it out after that. I wanted to help you expand this, right? So I expand these 2 and I got this. And then also multiply this by this to get it. Right? That's all the help I can give you. So we can figure it out there. Right? So anybody recognize what is a cubed plus b cubed plus 3a squared b? This here is equal to 5ab squared. So I can take off this and just add it to 3ab squared, and I'll get 8ab squared. So I can come back here now, right? And instead of writing a plus b all cubed, I could write log of this here. This here we simplify it to 8ab squared, and I'm dividing it by 8. The 8 will cancel, and you'll get log ab squared, which we could break up easily. Log a plus log b squared. I'm bringing 2 in front. Log to the base a plus 2 log to the base b. All right, and that was the answer. Why I divide by 8? Because I have this cube and this cube. 2 cube is 8. All right. So just somebody loves question. It has some more in the other years, like 18, 19, 20, right? There's only one that's a little, there's only one that like this with love. Not really hard. Sometimes every couple of years, it's been a tricky one. All right, but we have more to try, we'll try some more. All right, so next week we try to have a class at the same time. Most likely that class will be on, well, guaranteed it's online, right? And I'll do a couple of questions on this and start from stuff. Class Friday. Class Friday.